Alrighty, so we got to figure out this thing called domain. I'm going to keep this super short. I feel like I say that every time, and then I don't. But domain and everything that we've done in this class up to this point, and 90-some% of Algebra 2 kind of graphs is negative infinity to positive infinity. And that just means that you're good to go for any x value on a particular graph. Well, let me tell you that Santa over here, he's pretty cool. Let's see, he's pretty cool, I said. Oh, I gotta grab him. Santa's pretty cool, but his head will spin if he doesn't understand domains. Okay, let's see. Whoa, dizzy. Let's see what I mean by that. As he's going along on Christmas Eve and delivering presents to all the good girls and boys out there, well, if he doesn't understand that, whoa, see that vertical asymptote? He goes flying up here and then somehow he ends up down on this side. He will, I don't know, he will have to flip. And then the other thing he has to watch out for is he has to watch out for this hole. If he falls into the hole, you know, like goes in there and he'll never come out. So he's got to somehow skip over that hole. And that's what domains are all about, is skipping over those two things. Because yes, any x value will work going all the way out to negative infinity or out to all the way out to positive infinity. But we somehow have to understand how to skip over that vertical asymptote and under or over that hole. Okay, so that's the trick. And just to add a little bit of emphasis to that, I want to pop over here to my graph live on Desmos. And I just want to show you something. See the x values and the y values that are coming as I move this point along? And see that x value, it goes to, whoa, way over there. When it's negative, that's like I can keep going out and go to negative infinity. And then I go over here and I'm like cruising along. And I just want you to see that the x values are getting closer and closer and closer. They got the -5. The x values are -4s. But you know what they won't ever get to? Well, I'm going to try to get to that line, that 4, but watch what happens. Ooh, wait a minute. There it is. And then you see it down here? Then it flips down to there. So it somehow, it goes from way up there, -4.55 for the x value, and then all of a sudden it reappears on this -3 values. And so it can't get to -4. So we have to skip over -4 somehow. And the same thing happens when it gets to the hole. Watch what happens. Watch what happens. Oh, at 3, the function is undefined. And then we continue after that. So those are the two things that we have to watch out for. So when you're writing the domain for these rational functions, instead of this whole negative infinity to positive infinity, yes, negative infinity, yes, to positive infinity, but in between you have to do a little special dance. You got to go negative infinity until I get to this vertical asymptote of -4, and then I have to skip over it. And this is kind of algebra's way of showing interval notation. Go up to, but not really including -4, and then hop over to the other side of -4, and continue until you get to what? Well, remember the hole was sitting over here at 3. So continuing until you get to 3, and then somehow you have to skip over 3 and then continue to infinity. So this is a typical domain, and you're skipping over the vertical asymptote, and you're skipping over the hole in the graph. Now, it's not always in this order. It depends on which one comes first. So if I happen to have a hole in the graph over here, let's put it over here at -7, then it would have been negative infinity until you get to -7, union, -7, until you get to finally that vertical asymptote at -4, union, and that's what the U is, means continue after this. Then you pick up at -4 and go all the way out to positive infinity. So keep these in order from lowest to greatest of how it flips over. All right, kept that under 5 minutes. Sweet.